All right, so let's look at this question. It's an analytical geometry type of question. Basically, that means it's paper 2, and this will be around question 3, question 4 in that final NSC paper. That's where it's going to be. That's where you expect to find this question. All right, so let's start right away. We're going to notice a few things here. I just want to get you guys used to reading the statement and interpreting or applying this information given on the statement to the diagram. So we are told in the diagram, the circle having center R. So here's point R, and we know that it is a center, which means this distance, the distance ER, is actually the exact same distance as the distance RS, okay? We are just interpreting right now. And if you like, obviously, the distance RO is also the same as those two distances. All these are radii, okay? All these are radii. So that's why they are equal, because a line from the center to the circumference is the radius, and it's always the same. Okay, now, another thing that we are told is that the circle cuts the y-axis at E and S, meaning E is a y-intercept of the circle, and S is also a y-intercept of the circle. So it's very important to know what these statements mean. Now, the line through E and M, meaning E and M are on the same line. That's another way of saying E and M are on the same line. So that line intersects the circle, we are told, at U. It intersects the circle at U as well as the x-axis. And you see now. So in other words, another thing that they are basically saying to us here is that N is a y-intercept of the line. So, sorry, not y, but x-intercept of line NE. Now, this y-intercept is also y-intercept for line NE. I want you to see all this, okay? So let's take note of this. And then the next thing that I'm gonna do is we now gonna look at the last bit of information. UM is equal to ME. UM is equal to ME. Let me get a different color for that. In other words, this part here is equal to that part. So that thing is exactly the same as that, and obviously NR is drawn. We will see why later. Now, looking at these, before even looking at the questions, without reading what the questions require, you already anticipate to be asked the coordinates of E and S. You probably anticipate to be asked the point U. Of course, you will need the line NE for that. So we could expect then to find the equation of this line. That's another thing. We could maybe want to find out what the point N is, and I don't think there's much to do here. If we needed to find the point M, clearly is the midpoint between U and E, all right? That is that. Look at S, we could be asked to find the coordinates of S. Again, these are just things that should pop in your mind by just reading this question. Okay, let us look at the questions now. What is the first question here in line? All right. Cool. The first question there is right at the bottom. It says, give reasons why RM is perpendicular to UE. Well, this is theorem 1. If you don't know what theorem 1 is, go watch the grade 11 playlist. You will see theorem 1 there. So the reason is very simple. It is actually the converse, because the theorem says if a line is drawn from a center and it is perpendicular to a chord, then it bisects the chord. The converse says if a line from center bisects the chord, then that line must be perpendicular to a chord. So we are using the converse here, and that is why this line RM is perpendicular. Now we can fill that up in, we're gonna put a 90-degree angle there. and we're going to move on to the next question. 2 marks, right? Determine the equation of the line passing through. I'm just thinking about this question. Maybe you may say line from center bisects the chord, or if a line from center bisects the chord, then it is perpendicular to a chord. But I think they should credit you for both. The equation of the line passing through U and E in the form y equals to mx plus c. Now, think about this. We are told the form is mx plus c. So there are 2 important things when finding the equation of a straight line. Number 1 is the gradient m. Number 2 is the intercept c. Now, if you think about this, we have the point m. So we have a point on the line. So we are good. We will be able to find c. Our little crisis right now is the fact that we do not know what the gradient is. Now, this is where the previous question comes in. You will see in geometry, they like asking leading questions. So in other words, what you answer in the previous question will probably be important for the next question. So let us get to that. I need you to notice that little relationship between perpendicular lines. So we have established that MR is perpendicular to what? To UE. That means we have a right angle at M. So that's what it means. It means the angle UME is actually a right angle. And if that is the case, then we know that gradients of perpendicular lines are what? If you multiply them, you get -1. That's what we know. So if I find the gradient of MR, I will be able to multiply it by the gradient of UE to get -1. So we're going to use that principle. And I'll show you the quickest way to do this. Let's quickly calculate the gradient of MR. I'll call it MR. So maybe let me just write it nicely here. Small m, then I will go capital M and R. Changing Y. So I'll start with the Y at M, subtract the Y at R. The X at M, subtract the X at R. You just plug this in the calculator. Please save yourself some time. You are in your metric and time is very important when writing that. So you do notice you get a -1. So therefore, the gradient of UE is actually a +1. Why? Let's see. Because if I multiply the gradient of UE by the gradient of what MR, I must get what? A -1. And the only way to get a -1 is if this thing is a 1. So that is why, okay, gradient of perpendicular lines, the product of the gradient of perpendicular lines is a -1. So that's that. Now, that means so far we have the following. We have y is equal to x plus c. Why am I saying x? Because the 1 is just invisible, all right? Now, let's substitute that little point that I spoke about, point M, and find the value of c. So y is 8 and x is a -3 plus c. I really prefer using brackets, and it becomes clear here that c is equal to 11, which is just 8 plus 3, right? Therefore, here's your equation then. Y is equal to x plus 11. And I think with all the trouble we've gone through, this is worthy of 5 marks. It is worth 5 marks. They'll probably credit you for finding that gradient and for concluding that this gradient is that, and probably a 1 mark for the reason, then obviously 1 mark for finding that and a final mark for doing that. They'll probably credit you that way. Okay, that is that. Now, the equation of the tangents, we're not going to throw this away, but because I need space on my screen, I'm going to get rid of it, but I hope you have taken note of that or written it down somewhere. The equation of the tangents to the circle that are parallel to the x-axis. Now, if you think about this, remember I had said we probably gonna need to find the y-intercept. That is actually where it kicks in. So the y-intercept is point E, and we now know the equation of that line. And so it becomes clear that the coordinates of E are actually 0 and 11, because that's what the y-intercept is. And if you like, you can go ahead and find the x-intercept of this line here. I'm going to put it in. I hope you can see that when you solve for x when y is 0, you're gonna get an negative 11 and 0 here. So just like that, I then know, listen, remember this is 5, that is 11. Now, what is the gap from 5 to 11? I think that gap is 6, okay? Because 5 plus 11 is 6. And so the gap from OS to R should also be 6. Now, I know that from O to R, I have 5. So that means O to S must be 1. So that actually gives me the coordinates at point S. And those coordinates are what? 0 and negative 1. Take note that the tangents that are parallel to the x-axis basically are two lines that will touch the circle exactly at one point, and these are actually horizontal lines. So take note, there's one, and I can even draw another one here at the bottom. There's another one there. Here's another one here. So just like that, we are done. But how do you write this formally? Obviously, you will say the coordinates of E are what? 0 and 11. Y. This is a y-intercept of line NE. Okay? Therefore, the radius of the circle is what? 11 minus 5, which is 6. And that will actually give you the coordinates of S, which is 0 and minus 1. Now, your two tangents, okay? Therefore, now, E and S are points of tangency. Points of tangency. And because those are points of tangency, we can see from the sketch that those are horizontal lines. So y is equal to 11 or y is equal to negative 1 are your two equations. And I think that is indeed deserving of 4 marks. All right, let us have a look at the one but last question. Determine the length of NR. What is NR? Okay, N is just an intercept, R is that. I think this just needs the distance formula. So NR, we're gonna use the distance formula because we know the coordinates. It is not something that should really bug us up. Let's use the distance formula for that. I think you get this in the formula sheet. So the distance formula says change in x. So the x value at n minus the x value at r, square that, plus the change in y. The y value at n minus the y value at r, square that. That's what it is. And we can just keep this under the square root and just substitute. This is minus 11. Obviously, that's a 0. And what is y at n? That's a 0 minus a 5. We can square that. And at this stage, once again, I'll say don't take a risk. Remember, I can take the risk because I don't have marks to lose. So just hold the whole thing in the calculator. 11 squared is 121 and 5 squared is 25. We get 146. Now, what is the square root of 146? Well, 146 does not seem to be a product of a perfect square and a number. So we'll just leave it like that. It's just, yeah, typically the distance formula. Some people would have preferred to use Pythag, but I don't see the point there. If you know MR and MN, you can use Pythag to find NR, but take note, to find MN, you would still need to use the distance formula. So you can just go straight away into the distance formula here. All right. Now, this is the exciting question, the last one. We are told here that there is another circle that is formed, and it is formed such that it passes through the points M, R, and N. So there's an exciting one because we are being asked here to find the equation of that circle. How do we box that? How do we manage that? Well, let's see how we go about this. We obviously need to find the center and so forth. So here's something that I need you to remember. we have established. So the circle passes through that. Maybe let me draw this situation here. I'm going to use a pink color for this so that it stands out. All right. So look, there is a circle that passes through M. There is a circle that passes through R. And this circle goes on, and it passes through N and back there. All right. Now, we already know that the angle at N is a right angle. Then that means NR must be a diameter of the circle, this new formed circle. So I need you to know that. So we're going to start there. We're going to start there. Since the angle NMR is a right angle, then NR is a diameter of that circle, is a diameter of circle MRN. What's our reason? Well, this is the converse of a theorem that says angle in a semicircle must be a right angle. So now, excuse me, now that we know NR is a diameter, that means we must find the midpoint of NR. So somewhere halfway NR, we will have the center. So somewhere halfway here, whether it is here or there, I don't know, but we know somewhere halfway, we're going to have the center. And to find the center, in this case, it is easy to use the midpoint formula. So let's use the midpoint formula. The midpoint formula in this case, we will use it to say, well, the x value at N plus the x value at R over 2, the y value at N plus the y value at R all over 2. Let's do the quick substitution. Therefore, we will call that center. Let's call it center P. I hope we don't have point P anywhere then. Yeah, let's just call it center P. I can't use O because there's already O in the diagram. So let the center be P. Now the x at N is -11 and the x at R is 0. That's over 2. Y at N is a 0 and y at R is 5. Guess what? The coordinates of the new center should be that. Now, the equation of the circle would look like this. X plus 11 over 2 squared, y minus 5 over 2 squared is equal to what? R squared. I'm going to let you do this last one because it is a matter of substitution. To find R, you just need a point on the circle, and that is point R in this case. Point R on with coordinates 0 and 5 is on the circle. So go ahead, substitute the 0 here, substitute the 5 here. Use your calculator to find R squared. And then you would have completed this question. I believe I've done the long and the short of it, most of the stuff. I think if you calculate R and you, not R, but R squared, and you substitute correctly there, you should get something like 73 over 2. I think that's what you will get. And yes, that will complete the question. All right. Thanks for asking the question, and do share with your friends out there. Cheers.